Good morning, everyone, and thank you very much for joining us. And welcome to the launch of the Cross-Sector Battery Systems Innovation Network. We will be making a start promptly. I can see that the numbers are still going up, so still more of you are joining us, but just to keep things on time, we'll make a prompt start. So I'm Nicoletta Piperidou. I look after energy and infrastructure at KTN. And I'm delighted to have all of you here today. So at KTN, we are all about positive change. So we want to connect you and as many of you to drive innovation. And to do that, we help businesses connect with other businesses, business and academia. So we're all about making these connections live. And today we're here about making connections as well. But before I move into that, I'll just go through some minor practical aspects. So the webinar is being recorded and you will be receiving the recording after this. We have both a Q&A box and a chat box. So if you can use the Q&A box for questions to the speakers, we will be picking these up during the Q&A session. You can use the chat box for networking. So please feel free to type where are you joining us from today, what are your interests, why you're here today. So use this chat box for networking and use the Q&A just to submit questions. And if you have any technical problems at any times, please contact Poonam. So moving on to today, just some important bits of info. We have also set up Meeting Mojo. This is our networking tool. You can schedule one-to-one meetings with other participants. So please make sure to use this available networking tool just to meet more people. We have some slots scheduled and you can go in there, check your calendar, see if you're available for these, and then you can start seeing who else is on the platform, ask them to have a short meeting, and that will just help you to meet more people. Also joining later today for the Faraday Battery Challenge Round 4 competition that is at 1:30 p.m. today. So don't miss out and join us at 1:30. So I will now move on to the agenda for today. We have a lovely plan for today, which will start with some introductions from our chairs in just a minute, and we will then move on to hear more about the net zero agenda and the role for batteries. We will then hear from Anna and Martin on cross-sectoral targets for batteries, quick coffee break, and then some specific thematic case studies. Then we'll hear more about how you can get involved, Q&A, and close. So just a few words about the network. We've started in 2018 as a semi-formal group. We soon realized that there's lots of appetite, lots of people that want to connect. The community was growing. So we've received some funding back in April from KTN and the Faraday Battery Challenge to help us expand our activities. And today we're launching this network. So this network is part of KTN's Innovation Networks program. You might have heard it referred to previously as special interest groups or SIGs. So it is still the same program, lots of different projects, and our current program, the cross-sector battery systems one, will be running for 18 months. Just a few words on our founding members. So when we've started, we had a smaller core group, but very diverse. So aerospace, rail, defense, battery technology specialists, academia, all joining up for the same purpose. And yes, we soon realized that we need to expand. We need to have more of you involved with us. So the aim and missions for this community is to bring all of you together to help create new markets for the battery industry, promote innovation, and while we're doing that, we will also help decarbonize a wide range of end users. So rail, maritime, aviation, construction. There are so many sectors we can reach out to by innovating in batteries. So this is our project team. So myself and my colleague Shina Hindocha were leading this project, but we are also supported by a team of specialists, rail, maritime, aviation, low emission mobility, raw materials, energy and infrastructure. So pretty much any sector you would be looking forward to engage with, we have a sector specialist at KTN that can help you. And just I will say that I'm delighted to announce that we have appointed our 2 chairs for the network. Our chairs are Kevin Brandish, CEO of AMTE Power, and our other co-chair is Nick Carpenter, Engineering Director at Delta Motorsport. So I will now pass on to Kevin, and thank you very much for this, and look forward to a wonderful morning.
So good morning, everybody. It's an absolute pleasure to be here. I'm the CEO of AMTE Power, as Nicoletta said. I'm just going to say a few words about AMTE, just introduce the company and myself. So we founded AMTE in 2013, and the first thing we did was bought a business up on the north coast of Scotland that's been operating for some time, called AGM Batteries. And it's a manufacturer of cells, and I'll talk a little bit more about that in a second, but really our vision was to start to crystallise a lot of the innovation that had been in the UK for some years, but hadn't found an outlet into industry. And that's really our mission, to bring sort of differentiated products that are based on innovation and allow our clients a choice. So we work alongside some of the larger manufacturers. We're certainly not in competition with them, offering slightly alternative products and supply chains. The facility up on the north coast of Scotland is a full cycle cell manufacturing facility, which it's relatively small, sub 100 megawatt hours per annum, designed around millions of cells per year, so substantial in that sense. But highly flexible, and we can do both cylindricals and pouches, different chemistries, rechargeables and non-rechargeables. And it's that flexibility that we've used over the last sort of 5 years to start to develop an alternative product line. And here are the 4 that we have sort of focused in on. Again, all slightly different from a standard lithium-ion cell, but all based on lithium-ion or lithium-ion derivatives. So we've got a lot of work on high power. We've obviously got an energy cell. The ultra safe cell is a slightly different chemistry. It's sodium ion, has some real advantages. And then the ultra prime is a high capacity primary cell. So we've been developing these cells against markets with our clients, and we're looking to launch those from next year. What markets do we work in? Well, we do have a link into automotive, but it tends to be more specialist vehicles, performance vehicles and off-road vehicles, rather than more mainstream. Aerospace, oil and gas, and of course energy storage. So a range of markets. That's the good news about cells. They can apply themselves across quite a wide range of markets. And whilst we have the facility up in the north coast of Scotland, we recognise it's quite small. So we've been designing a larger factory, and this is just showing you the outline. There's been quite a lot of publicity around it. We've got a couple of locations selected, and we're looking at a sort of gigafactory, but a single-digit gigafactory coming online in 23, 24. So that's the ambition. And that's really just to make sure that we can follow the demand that our clients are identifying. So as a business, and you know, we're focused on some of the slightly different markets as compared to mainstream automotive. And that's really why we were a founder member of the cross-sector battery group. because we recognised that there was really good linkage already in mainstream automotive, but perhaps less so beyond that market space. And mainstream automotive is driving the majority of cell and battery development, but there are other clients who need solutions as well. So the group really is there to ensure that everybody beyond automotive is aware that there is a supply chain available to them, to try and find enough volumes across those different parties that we can build to that gigawatt hour plus production and make it as cost effective as possible. And also to enable networking, and particularly those innovating, to see that there is a manufacturing route to follow into that market space. So delighted to be chair, and I'm going to hand over to Nick to continue. Thank you.
A quick canter through some of the things that we're involved in as a business. You probably won't be surprised to hear that we engineer and supply battery systems, and that's into a wide range of applications. The guys from AMTE Power tend to deliver, as Kevin has said, sort of niche automotive, but then out towards off-highway and so on. Whereas we tend to focus, or have focused, on the niche automotive side, out in towards more mainstream automotive. In-house, we're focusing very much on the low volume product, prototype vehicles, low volumes, whether 2 wheels, 4 wheels, or more, in some cases none. And then what comes from that, of course, is a requirement to build a reliable supply chain. And that includes battery cells, of course, but it also includes most other components in terms of the proprietary parts. So the battery management system, electrical distribution system, and so on, we need to bring together into a coherent whole. And then what we're looking for is to build those partnerships further for a volume capability to scale up for those customers who want to be able to do that. And then how that sort of reads across into the cross-sectoral requirements is that we're trying to learn rapidly about the application-specific requirements. So we've done a lot of work building our competence and knowledge on mainstream automotive and niche automotive, and we need to then reapply that thinking, that approach, that philosophy elsewhere into other non-automotive applications. We're looking to see how we can use the supply chain and improve the supply chain, and then in some cases highlight to government, Faraday Institution, Faraday Battery Challenge, regarding where we see holes in that supply chain. So as a business, we were formed just over 15 years ago, as the name suggests, as a motorsport consultancy. But both myself and my business partner came into the business, set the business up with some non-motorsport experience as well. And we're growing the business pretty rapidly. Now we're up to 50 staff across 3 units at Silverstone Technology Park. And we're just in the process of moving into a bigger facility, nudging 10,000 square feet just for battery build and development. And that gives us a huge opportunity then to develop subsystems, modules, components, and then on up into full battery systems. So we've done a variety of battery system development over the course of the last 10 years across hybrid and battery electric. And one of the early hybrids was work with the microcab guys on a hydrogen fuel cell vehicle. But then by 2010, we've engineered our own vehicle, the one on the right-hand side there, that many of you will be familiar with, I'm sure. We're then growing that capability out beyond sort of 1s, 2s, 5s and 10s. Across the last 10 years since we did that vehicle, we've really applied that very broadly into high performance automotive prototypes for OEMs, for low volume production, in some cases just design with other people manufacturing on our behalf, in some cases manufacturing what other people have designed. And then now we're moving in towards the automotive sector as well, the ultra popular skateboards that are out more and more over the course of the last couple of years. We have a very flexible engineered skateboard available to adapt for different vehicle types. And as it says there, the capability is now growing into non-automotive applications, including marine, a little bit of aerospace, and some off-highway. So in terms of our capability, we're looking at a range of volumes, a range of applications, and a range of requirements. And with that in mind, we did 2 rounds of the Amplify project, the first one as an IDP project, the second as a Faraday Battery Challenge project. That has put us in a position where we can engineer and build modules based around cylindrical cells, either 18650 or 21700, with a range of parallel and series arrangements. And those are capable of anything between 2C and 20C peak discharge, so potentially very high performance liquid cooled cylindrical cell modules. And then beyond that, if you're looking for greater than 20C capability, which is often the case for hybrid applications, we can take pouch cells, and we're in discussions with AMTE Power at the moment about their high power pouch cell capability, and that takes us all the way up to 100C, again with high thermal management capability. And as I mentioned before, the increased facility size gives us that capability to build modules and then test up to 120 volt module and 100 kilowatts, which is a huge capability for us. So one of the things that we're very aware of, and something I would make everybody aware of, is that when you start to look across the sectors, each of them has key challenges or key requirements, if you like, whether that's safety and power in aerospace, and that's largely power density, so gravimetric power density, which is actually very similar to motorsport applications. Across the grid, it's all about cost and life, and you can bring the 2 of those together and say that's probably cycle cost or whole life cost. Construction is often power density, high peak power requirements in some of those machines rather than necessarily energy. Although depending on the application, you sometimes find that increasing the energy to deliver across a working day gives you the power capability as well. As far as rail is concerned, it's cycle life and predictability of that performance as well, and there'll be people talking about most of these a little later on in the presentation. And then from a marine perspective, it's life and it's also volume. So then, just to wrap up, some of the real challenges that we're seeing when you look at cross-sectoral battery systems as a broader question, and there's huge differences between the various different requirements. Scales working from less than a kilowatt hour up to hundreds of kilowatt hours. You think volume and timing in the automotive sector is a little bit unclear, but across many of the other sectors, without perhaps the legislative or commercial drivers, the timing is even more unclear. The technical requirements, as touched on the previous slide, are different. And then working through that market pull, as I touched on a moment ago, is pretty challenging. What is it that's actually driving the need for electrification? And that's why, as a potential supplier into those systems, having people we can engage with directly across those sectors, whether that's marine or rail or defence or whatever, just shortens that loop between what we know and what those customers are going to need. So that helps us pull things together much more quickly. So that's it for me. Thank you very much. If you could hand on, Stefan, to the next presenter.
Thank you very much, Nick, and thank you very much. I'm now delighted to welcome Tony Harper, Challenge Director, Faraday Battery Challenge. Thank you.
Good morning, everyone. Yeah, so for those of you that don't know me, my name is Tony Harper. I'm the Industrial Strategy Challenge Director for the Faraday Battery Challenge, which means I have the pleasure of overseeing all of the elements of the government's investment through UKRI into batteries. I thought I'd just give you a little bit of background and perspective on today from my side. So, as many of you will know, the Faraday Battery Challenge kind of started or was conceived around 2017. That was the time when, certainly for mainstream automotive, the timing of the CO2 requirements, certainly in Europe for passenger cars, and to a certain extent globally, was starting to crystallize. And manufacturers were putting together their technology and product roadmaps to be compliant with those regulations over the next 5, 10, 15 years. When you do that, you realize that a very high degree of electrification is required, and that an awful lot of batteries are going to be required by the OEMs. And in the UK, we started to translate that into numbers through the Automotive Council at the time. Those numbers turned out to be very significant. So even if we just take the European CO2 fleet average regulations as a driver, let alone banning internal combustion engines by 2035 or whenever that turns out to be, which will pull things forward, if anything, we worked out that we'd need somewhere, in the region of 100 odd gigawatt hours of battery demand or capacity in the UK, on the assumption that we continue to make as many cars or slightly more cars than we do today. Now that turns out to be about an £8 billion opportunity. At the same time, we make 2.5 million engines in the UK today. That again is an £8 to £10 billion business, which is of the same order of magnitude. So we were clearly going to lose one over time, and if we didn't take action, we were not going to replace that with a battery industry. And so, based on mainstream automotive passenger cars, it was relatively straightforward to make a case for intervention. That's how the Faraday Battery Challenge started. £274 million intervention in research, business-led innovation, and scale-up activity. And now that's grown actually to the point that we're now a £317.5 million challenge today. Now, as we go, so far so good, and all of the targets, the technical and commercial targets that have been driving the research and innovation and scale-up activity have been based on the 8 targets that Automotive identified back at the time. Now, they in and of themselves are evolving, as you'll probably hear later. But the world has moved on since 2017, as we know, in many ways. One of the ways, that significant ways that it's moved on, is that we now have a legislative commitment to net zero across the board. And if you just take transportation, air, sea, and land, let alone energy, that's about transportation is about 28% of all of the country's CO2 emissions. Energy is about another 23%. And we need a roadmap for all of it. Yeah, not just passenger cars. And if we just take transportation, obviously that includes land, sea, air. So for some of the land applications, they're much more harder to decarbonize than passenger cars. For some aerospace applications, as you'll be hearing later, some of them can be fully electrified. eVTOLs, perhaps light passenger aircraft, but some of the others are going to need other solutions, maybe hydrogen, maybe ammonia, maybe sustainable liquid fuels. But all of them are going to need batteries of some description. Fuel cell applications need batteries to buffer between the transient demands of the application and the set point output of fuel cells. And even where you've got liquid fuels, you're still going to want a degree of energy recovery and the electric drive of ancillaries and so on. So all of them are going to require batteries, and I haven't even talked about stationary yet. But as has been hinted, you end up with a very diverse set of targets, not just the targets that you've got for automotive today. You have some applications that are very power biased, some combination of power and energy. For eVTOLs, you need very, very high C rates. For anything that needs a quick turnaround, quick charging, you need high C rates, etc. So we're seeing a diversification, a crystallization of those targets, and that needs to be the focus going forward, as well as, don't forget, the passenger car story hasn't gone away at all, and in fact it's getting more challenging. So overall, we've got a need to share targets and requirements across all those sectors amongst a whole bunch of stakeholders, people who can provide solutions, maybe their supply chain, other people that have got similar targets have got opportunities to collaborate. And I've been watching the chat actually, and it's reminding me that if only everybody in this community knew the sum total of what there is to know, we would be able to collaborate and innovate much quicker. And that's really what this innovation network is about. We need to be able to share targets, requirements, capabilities, and that's public capabilities as well. I've seen the High Value Manufacturing Catapult and Faraday Institution, all sorts of it. We've got massive assets, very significant assets all around us. And this innovation network, we want to provide the platform for the sharing of requirements, the sharing of capabilities, and also a platform for consortium building and wider collaboration. So I'm delighted that we've got 177 people online, and I'm delighted that that this is being launched today, and also we've got our competition for CR&D launched later this afternoon. So I encourage everybody to participate in this, and tell your friends, 179, tell 100, other 179, etc. And let's use this as a platform for accelerating our journey towards net zero, but also our journey towards making a business as a country out of the journey to net zero. So thank you very much for listening. And I think I'm now handing over to Anna and Martin.
Many thanks, Tony. That was excellent. And as you say, lots of messages on the chat. That is great. We would love to build the community. So keep the messages coming. And at the end of today's webinar, I will tell you how you can sign up to the network and become part of the community. So I will be sharing with everyone the links. Thank you very much again, Tony, and I will now pass on to Anna Wise from Innovate UK and Martin Dawson from Warwick Manufacturing Group. Thank you.
So yeah, good morning, everyone, and thanks very much for joining us today. It's really great to be here with all of you. So I'll just introduce myself briefly. So I'm Anna Wise, I'm Head of Battery Technology at Innovate UK. So I work with Tony on the Faraday Battery Challenge. So I've mainly focused on the business-led research and development, but interested in technology development across the TRLs. So yeah, been working very closely as part of the cross-sector core group that Nicoletta mentioned, and will continue to do so with the Innovation Network now that we're going live with that. So Martin and I will be taking on this session. So Martin is the Battery Systems Research Manager at WMG, and we've been working over the last, well, quite a few months actually, on developing and trying to understand the targets and priorities for cross-sector battery applications. So it's been touched on obviously by Nick and Tony, that we're understanding more and more and seeing more diversification in the requirements for batteries. But also trying to understand where there might be overlaps and opportunities for technology to coalesce some of those performance requirements, and really understand what the demand is and where the research needs to go to get us to net zero with electrification. So just to sort of give a bit of background, so Tony mentioned this previously. Initially, we started off very much thinking about, from a Faraday perspective anyway, electrification for volume automotive applications. And back in 2017, a lot of work was done to develop roadmaps for electrical energy storage for those volume automotive applications. So this was work led by the Advanced Propulsion Center on behalf of the Automotive Council. And through this work, there was the technology roadmaps for the different cell and battery technologies that could come forward over the next, between 2017 and 2035, and also how the performance of the batteries could change during that area and how much they might need to actually change during that time frame. And we very much use this as a guide, as a direction of travel to help focus some of our thinking, not using it as it has to be following this path, but it's very useful as a way to understand where we're going, how are we tracking, and what needs to be done. And so what we wanted to do was to try and sort of replicate this for other sectors and understand, how does the technology need to develop, and to what point do we need to move that technology on. So, sorry, there we go. Okay, so in terms of those eight targets, what they were focused on is sort of 8 key areas. So looking at cost, energy density, power density, safety, life, temperature, and then predictability and recyclability. Really, how cheap can we get these batteries? How cheap do they need to be for electrification to be viable? In terms of the energy density, where are the opportunities to improve? To what extent can we improve? Looking at lithium ion, but also beyond lithium ion. With the power density as well, looking at how high does it need to go? And it should be noted as well that for these particular 8 targets, and for the numbers that are involved that you're seeing here, they were not necessarily designed to be taken simultaneously within the same battery. So it was looking at at the sort of best in class, depending on the type of battery, type of application, still within automotive that you were looking for. So yeah, so very much looking at how we focus our efforts to really bring that forward. So really, thought, we'd be able to take this idea and translate it to other sectors to try and build up that picture. So that's what we set out to do. And yeah, as I said, very much has been automotive focused to date. Yeah, so very much automotive focused to date, but how can we apply this approach and understand the performance requirements for multiple sectors, and also how that maps to market opportunities for different technology types, different applications. So where are the overlaps, and where are the priority areas for research? So where are we furthest away from being where we need to be, and what do we need to do to get there? So the aim, as I said, was really developing this set of revised targets to promote this appropriate research and enable the successful future exploitation of batteries and cross-sector applications. So that's sort of giving a bit of a background as to what we set out on this activity and what we kind of hope to do. I'm going to hand over to Martin now, who's going to go into a lot more detail on sort of the approach and what we found. So Martin, over to you, please. Thank you.
Thank you, Anna. Right, okay. So I'll briefly run through the approach and give you a flavour of where things are going. So the first thing to start with is trying to actually redefine the baseline, as well as the need for cross-sector. What we also discovered that the actual state-of-the-art on batteries had moved rapidly and already, in particular, cost-related, overtaken previous predictions. So it was definitely time to do a redefinition of where we thought we were and then continue the walk forward for cross-sector. Trying to understand, therefore, what the requirements are from new and emerging sectors, but more importantly, what are the key strategic drivers for each major sector? So this also includes the business, commercial and market equations, as well as the technical drivers for each sector. And as Anna said, the previous set wasn't a balanced set of targets for one application. So what we felt was, how do we give people a flavour of what the balance should be? Because you could still have a stretching battery target, but none of the individual metrics themselves are best in class. It's just the combination of them together have never been seen. So what we're finding is, yes, there's a push for energy density or cost, but sometimes there's a push for a strange and different balance for new and emerging sectors. Then the biggest challenge is then how do you actually bring this all back together for a simple high-level summary? The previous 8 targets worked well because they were easy to communicate and articulate, especially when you start engaging on the political side. As we go cross-sector, this becomes very complex indeed. And what we want to then also try and do is feed into the targets into APC work streams and also ATI on updating the technology route maps. So the cross-sector journey, the first thing as well to run through was actually the original 8 targets, just the level of complexity of the metrics. So just on the power side, were we talking peak power, continuous power, charge acceptance or discharge? So what you find is that, again, you can actually very soon start growing into just definition of the metric, causing a level of complexity, and especially when you apply it to other sectors. Some sectors want power at low SOC, some want them at full SOC. So again, it's very hard to try and get a one-size-fits-all solution for this. And the complexity therefore suddenly goes exponential. You get subsectors within sectors, you get subsectors of that. So what we try to do is pull it together in sort of clusters to try and simplify the task of understanding where the gaps were, what the key performance drivers were for these sectors and clusters, what really actually makes them viable from an electrification perspective. So we wanted to capture this variation of requirements within a cluster as well. And also try and highlight the potential areas for focus for the future, and bring it back to the whole reason to do this. So really the idea of doing all this is actually today is to also try and get feedback and discussion going. It's been a fairly complex thing getting requirements because you're torn between what's in the public domain and what's not. A lot of OEMs don't want to actually disclose their future strategies and therefore don't want to give you too much detail on what their targets and requirements are. So I've had to do a bit of balance from my own commercially sensitive knowledge, trying to desensitize it, but also my own experience in the past of designing various electrification products. But it'd be good to get a feedback from the wider sectors, whether we think we're heading in the right direction. So we don't want to get into have we got exactly the right number to the dollar or to the watt hour a kilo, but more, is it highlighting where the real gaps are, the direction of travel, where we need technical solutions? Have we got the right balance of attributes, etc.? So apologies if you think this is slightly blurry, it's not your computer. This is an excerpt from the discussion document that Anna and I want to publish in the next couple of weeks to you all, which will actually take you through a bit more of the detail. Don't have time today to take you through everything, but this gives you an idea. One of the ways we try to simplify things back down into these clusters and the different sectors. And what worked quite well was just plotting power density versus energy density. And what we found was there was 4 main clusters started to appear. So there's the main one is probably driven out of the automotive world, and energy storage it's focused on energy, but it's very cost sensitive. Adjacent to that is an energy focused sector, but it's weight and power sensitive. So this is the emerging area of electric aerospace, eVTOLs, but also some of the performance motorsport and very high performance road cars are very interested in power, but need lightweight. Going up the y-axis, there's a power focused but cost sensitive zone, which is where your conventional automotive, mild and full hybrids, but there might be some hybridization of rail and other products forming this sector. And then the probably maybe the lower volume, but still technically challenging from a power perspective, is a power focused region, but very weight sensitive. So the very top of this is probably a Formula One KERS cell. But there are some emerging ones, as Tony hinted at, that with hydrogen, there's still a need for batteries, and there are some requirements for lightweight, high performance batteries to go with the range extender type systems. This is just a snapshot of all the sectors. On top of this, you could even overlay defense versions of all these different sectors and subsectors. And there's probably things we've missed and other ones that will fall into different sectors. So this one's just a zoomed in version of the bottom right to try and give you some more granularity. Things like automotive PHEVs, motorbikes, e-bikes, and also something I've classed as low cost mobility. We're now seeing people willing to trade energy density for actually even lower cost on mobility. So there's not always the race on for ever increasing energy density. Okay, so these then will include 4 breakdowns of each of those clusters. And we've put a sample, sort of a notional balanced set of targets picked from one of the type of products out of the cluster. So hopefully that can give people a bit of a flavour. I think on my screen I'm just missing it off the bottom, but we've also shown a cross-sector variance to show that even within a cluster, for one set of balanced targets, you still can get quite a big variation of requirements. Right, on to the next one. And this is the second pair of clusters. And each of them throw up different levels of research challenges at cell level or pack level, etc. So you'll be able to read these at your leisure when we send this out. But also what we'd like of you on to the next slide. Oh, back up one. Then there's some targets out of the original 8 box. So there was safety, temperature, predictability, modeling and recycling, where we've tried to group these actually as relatively common across sectors. That's a bit of an oversimplification, but to try and keep the complexity down, I've just tried to do these as more of a word description of the direction of travel. So definitely welcome a lot of feedback on how to do these. The complexity with this is how we can keep it succinct but also actually articulate the challenge and direction of travel clearly. Right, on the next one. Oh, back up. Oh, there's, I think if you can go back up a couple. Yes, I think I've discovered my computer. Sorry. It's not quite going back up, but okay, we'll miss out. There was a slide. It's okay, we'll go back on. I think I might have missed it out myself. There was also meant to be a slide showing a balance of the priorities across the sectors, but you'll see this when we publish the deck for review. So if we now move on, and Anna will join in for the last slide, how do we get feedback and how do we move forward from here?
Brilliant. Thank you very much, Martin. So as Martin said, one of the key things that we really want to want to be able to ask you for your contributions on is understanding some feedback on what we're looking to publish on these clusters, on the direction of travel. So really very keen and would encourage you all to join this innovation network and to provide some views and feedback. This discussion document. It is very much a discussion document. We're particularly keen to understand if you have any concerns, issues, or notice any gaps with the numbers or with the clusters, with the priorities in particular. So from an automotive and an aerospace side, we're closely linked to the Advanced Propulsion Center and also ATI on the aerospace side. We're looking to establish equivalent links with other sectors through this innovation network. So if that's something that you would like to be involved with, then please do get in touch and let us know. So as Martin said, we will be sharing this PDF of the discussion document with you over the next week or two. And there will be an opportunity with that to provide feedback through the website. And we'll be looking to include this feedback and present an updated version at LCV 2020. So that's in November, I think 17th, 18th of November. And following that, what we're looking to do with this is develop an interactive platform, which will be hosted on the Innovation Hub, Innovation Network website, and continue the evolution of targets from there with all of your contributions in that. And that's something that will evolve over time. So yeah, this is very much the first step, first discussion document, and very keen to share with as many of you as possible and get your feedback on what we've put forward. So that's great. Thank you very much. And so I think now I hand back to Nicoletta. Is that right?
Many thanks, Anna, and many thanks, Martin. That was excellent. We've looked at the document before, and it has it's a very rich material. So probably people would actually need to go through it and read it in detail before they are able to come up with specific comments and questions, which is completely understandable. But you will be all receiving the material, so you'll have a chance to review it. As Anna was saying, the plan for the community is to have an online hub where all of you can join and find the latest reports, latest news, connect with others. So we want to create a community for you, an interactive community based around an online hub that you can make the most out of it. So this is currently being developed in the background. The online hub is not yet live. It will be live in a few weeks' time, first in a beta phase for a small group to give feedback, and then open to all of you. In the meantime, what we've done is there is currently a URL which I'll be sharing over the chat and in the follow-up email, ukbatteriesnetwork.org. So currently, this will be the link for the online hub. Currently, this redirects you to the KTN website, where we have an interim web page for the group. You will find also there a sign-up form where you can sign up to stay in touch with all of us. Again, I will be sharing all these links via the chat and in a follow-up email, so you won't be missing out on anything. Once the document that Martin and Anna have been working on is finalized and uploaded there, you'll all get a notification and you'll be able to submit your feedback. So that's the plan. We will be now moving on into the Q&A session. So now it's your opportunity to submit questions for what you've heard so far. We have already a couple of questions coming in, but now this is your chance to ask your questions. So please use the Q&A box and type there any questions you might have. We're more than welcome to help you. The first question we've received is, what are the opportunities for structural batteries capacitors in electric and hybrid vehicles? Are supercapacitors safe for crash worthiness? So this question came in through while we were through your slides, Martin. So I'm assuming it was addressed to you, but yeah, you can start, or we can open it up to the rest of the panelists.
Well, I can have a go at trying to answer it. So the opportunities for structural batteries or capacitors is high. It's actually one of the key drivers will be reducing cost, as well as primarily rather than weight, but effectively structural batteries offer the opportunity for both. So it's less complexity, less weight, less material, therefore less cost. So that is the big driver for a lot of OEMs at the moment. The safety side of it is, yes, potentially the challenge. It doesn't just apply to supercapacitors, but to conventional lithium ion. So a lot of it actually drives probably better modeling and simulation and understanding of structural integrity of supercapacitors and lithium ion cells in crash mechanisms. So how much deformation can the battery take? Traditionally, people have avoided, almost put a ring of steel around the battery. But to go more integrated into the crash, you've got to have a lot more subtlety, which requires better modeling, etc. So that is the challenge to make it safe. And partly, I think that's why we've tried to put in the target deck things like improved modeling capability to support things like this.
Many thanks, Martin. I'm not sure if any other of our panelists would like to comment on this. Otherwise, I will just move on to the next question.
What's the second? Oh, good question.
Yes, the questions keep coming. So on one of the slides,
what's the second E in eVTOL? I'm never quite sure. What it just does mean vertical takeoff and landing. Yes, I think the second E is just from vertical.
Yes, that's good to clarify. Again, in the document, the acronyms will be explained, so you'll have a chance to look at that in detail. So actually, there was a question earlier that Kevin answered over the chat, but questions that are answered privately in the chat, other people can't see. So perhaps I will just ask the question to you, Kevin, so that everyone can hear. So someone was asking if you supply batteries in the defense sector.
Yeah, I mean, the business has a very long history of supplying into defence. And the new products we've aligned are suitable for defence. So the answer is yes, and we'd like to continue and grow that trend.
Perfect. Thank you very much for that. Then we have a general question to all presenters. What is the outlook for battery raw material supply chain in the UK, especially after the Brexit? So that
I think it'll be challenged before Brexit, but I guess Kevin might be best placed to answer the raw material supply chain side.
Yeah, I can certainly answer that. I mean, part of the driver of setting up cell manufacturing in the UK, and we're not the only company looking to expand into that space, is to take that challenge away. Now, of course, we have a supply chain as well, but the chemical industry is growing in its ambition to be part of that supply chain too. So we've been working very hard, and again, it's a it's a link we want to form in this KTN is to the chemical companies, because yeah, we've been looking at forming a UK-based supply chain. I think we might be a little way off that timing-wise, but certainly we have the capabilities to do it. And there's been some studies done by the Faraday Challenge, which Anna or Tony can refer to, in fact, by APC, I think, that does show there is a great opportunity here to enter that space.
Thank you very much, Kevin. I'm not sure if any other panelists might like to share some views on this battery raw material supply chain. If anyone else has any thoughts on this? I can't see anyone jumping in, so I will move on to the next question, which is, what are the impacts on recycling of using structural do you think it rules out second life applications?
I think I can have a go at this one. It definitely makes it more challenging. So if you've seen what Tesla have just done, they've in effect made a single giant module of cells bonded together, which would be very hard to do a second life repurposing. I think it'll be some time before everyone goes to very large format modules, and it's probably more dominated by the automotive sector going for very low cost. So it'll be related to high volume manufacturing. But yes, it does make it more challenging that OEMs are more worried about first life cost than making second life battery easier.
Thank you, Martin. Again, if anyone would like to add any further thoughts on this. No, I will move on to the next question. Would be interested to hear thoughts on current UK competitiveness across different attributes. For example, performance, cost, sustainability. Where do we see strengths and need to develop? So this is an open-end question, I guess.
I think it'll probably be a Kevin and me tag team on this one. Well, Kevin could probably answer it all, but from my perspective, I think the UK is definitely competitive on performance, very high power cells and niche cell manufacture and design. I think Kevin hopefully will back up where we'd class ourselves as very competitive. The cost side is the tricky one, and that's what Kevin again will articulate why the need for a gigafactory, because it's more driven by the manufacturing plant scale of your plant and productivity and throughput. Sustainability, yes, the world's starting from a relatively low base, but there are a number of work streams kicking off where we should be very shortly competitive on that. So Kevin, you can top up where I've missed off.
Yeah, no, I think you got most of that spot on. The competitiveness when we come to performance and more specialized cells, we're absolutely competitive. In some areas, I would say we're getting a world lead. Cost-wise, it relates back to the type of cell you're looking at. For specialized cells, we can be very cost-effective. Really, a sort of more mainstream cell, a fairly sort of standard energy cell, that relates to volume. If we had a volume production plant in the UK, we could also be competitive because it's the volume that really drives this more than anything else. So absolutely. And I think I'll add on sustainability. We have got a reasonable level of low carbon power available, and it's one of the key features in the sustainable argument of the actual cell production and thereafter. And of course, you've talked about access to supply chains. There are lots more lithium supply sources coming online, so that's okay. And then recycling comes into it again. And that's something I think that the UK is working hard on, and we're certainly involved in putting that recycling aspect on the end of the life of the cells. So generally speaking, I would say we can be very competitive, but it does relate back to volume. And again, part of this community is to see where the overlaps line up so we can establish those volumes.
Can I just add, it's Nick Carpenter, can I just add, Kevin and Martin there, that I think that reads up to battery system level as well. When we talk about batteries, are we talking about battery cells or battery systems? Actually, I think the story is fundamentally the same, whichever way you're talking about it. So those niche applications, whether it's motorsport, aerospace, niche automotive, defence, we're pretty competitive as a nation at turning those appropriate, and I would call good value, perhaps, cells into battery systems. And those are generally quite small in terms of capacity. Mentioned earlier, hundreds of watt hours, maybe a few kilowatt hours, if you're lucky, a few tens of kilowatt hours, rather than up to mainstream automotive. And at that point, the value comes from the engineering capability, the understanding of the requirements, and I think that is somewhere we are particularly competitive.
Thank you very much, Nick, and thank you, Kevin and Martin, for all of you for answering to this question. Lots of discussions about recycling and sustainability. So I'm wondering, Jackie, if you would like to say a few words on the work you've been leading on with the Sustainable Batteries Group, just to reassure everyone that we are thinking about it and things are happening in the background.
Yeah, sure. I mean, I'm looking at a report at the moment, and I can't share it because it's a subscription report that shows actually on regulations, innovation and infrastructure, the UK is ranked sort of number 4 in the world, and that fits alongside the downstream demand that we're sort of talking around very clearly here. Hold on a second. Can I just get rid of my puppy from the background? Otherwise I'm gonna, I knew that was gonna be an issue. Sorry guys. Anyway, so we know we've got strengths in this areas. One of the things we've done is try and join up across government, but also use what we have. So when you look at things like UK BIC, for example, they learned and a lot from actually AGM batteries, for example, on the permitting side and planning side. And we've built that up, and actually obviously that knowledge stays in the UK and something we can share. And the Sustainable Batteries Group that you're talking about is a group where I'm a big fan of practitioners, shall we call them, doing the knitting. And I think that's what Martin, this group is really about as well. It's about actually getting people who really do understand things like the legislation that interacts in this area. And we have, you know, it's how do we get that all to work together? It's taking that systems approach. And actually quite often that isn't about coming from top down. It is about getting practitioners into a room to figure it out. And I think that's exactly what this group is on. And we do look at raw materials, mainly on the recycling and sustainability, the life cycle analysis side. And the reason why I say mainly is because actually the supply of raw materials and the supply chain is being picked up by the Advanced Propulsion Centre, who we also work very closely with, and the Automotive Transformation Fund. And I think that's another big key pivot in the UK that will help us really advance our competitiveness. Does that help, Nicoletta? And I'm sorry about the puppy Zoom bomb that just happened. I knew that would happen at one point.
That was perfect, thank you. And actually we are perfectly on time to now move on to a 10-minute coffee break. So this is an opportunity for all of you to top up your coffees, stretch your legs, and we will reconvene in just 10 minutes, 10:45. During the coffee break, I will pop in some links in the chat just to remind you about Meeting Mojo, signing up to the group, etc. So keep an eye on the chat, and please keep using the chat for networking. Thank you. So now we will be moving on into more practical case studies. So looking into rail batteries for rail, aerospace and defense. So I will be passing on first to David Dempsey of Angel Trains. So over to you, David.
So, morning all. This is about batteries in rail. My name's Dave Dempsey. I work for a company called Angel Trains. Just by way of introduction to who we are a rolling stock owning company formed in 1994 out of privatisation. Through privatisation, we inherited a number of British rail fleets, which are comprised of diesel and electric traction vehicles. Currently privately owned by a number of private investment businesses. And to date, we've invested £2.3 billion in new build, and that's increasing to £3.5 billion with new orders on stock. And we've spent over £1.2 billion in refurbishment enhancements of those existing fleets. We are solely focused within the UK passenger market, and we currently own circa about 5,000 vehicles, give or take, new build coming in and old vehicles being scrapped. And we have approximately a third share of the market, though that is slightly reducing with some of the new build and investment possibilities that are coming through. The average age of those fleet is 24 years, but this is reducing to 17 years. And we have an expectation of a fleet going for about 35 years. And that's quite important when we certainly look at some of the new build that's gone on recently with diesel vehicles coming in 2020. They would be looking at going out about 2055. We currently have about 130 employees, and 40% of those or more are engineers. So why we're talking about rail, we're quite niche, and certainly within this area as well, and with this chat. And we talked a lot about roadmaps to decarbonisation. Here's the Automotive Council UK roadmap. And what's clear is this is automotive, and rail just doesn't have its own roadmap at this particular point in time. However, what the government has said is they have an expectation to end diesel-only trains by 2040. The key word in there is only, so diesel only. So diesel traction trains cease, but by modes, etc., are perfectly fine. However, this 2040 is being made more stringent by cities such as Glasgow, claiming they will go carbon neutral by 2030, and a lot of other cities following suit. Now, diesel is extremely important to the rail industry, and what we've got is we can see quite clearly it's the most polluting, giving out the most CO2 emissions. If we compare that to electrification, electrification is seen as being one of the most green ways of rail traction. What we can see is hydrogen can be just as poor as diesel, with the well-to-wheel emissions not really much better than diesel, depending on where you get the hydrogen from. And what we've got is we're looking at hybrids, and hybrid can save between 1/4 and 1/3 of the emissions of diesel. Now, everybody talks about CO2, but DEEE is probably far more important at this point in time for rail traction. However, if we pick up sort of sources of NOx and PM, rail itself does not feature very highly, and road transport tends to cop for most of the emissions. Rail vehicles have moved. We've improved on the diesel engines that are out there. We've provided newer engines that meet more stringent standards, saving quite a considerable amount on NOx and PM. I mean, 40% on NOx has come off and 90% of PM. But it's still a major issue, and that's caused in problems like major rail hubs like New Street Station. This is subject to studies through institutions such as the University of Birmingham into the long-term effects of working in these conditions. But this is a covered station which has diesel trains coming in and coming out. Now, they have tried to reduce the amount of DEEE and the emissions that are going on there by having fans to pump out it, and actually reducing the amount of time people can work there. And they also have engines off in stations if the unit is to stand down for more than 12 minutes. However, but that still causes a problem. So why do we use diesel if electrification is is the answer? Well, rail track there's about 31,000 kilometres of rail track. These are network rail figures from 2012. And approximately 40% of those are electrified, leaving 60% are not electrified and in need of diesel usage. Now, the cost for electrification was reported at £2 million per mile on the Great Western. So it's considerable amounts, and that has led to the Secretary of State announcing the cancellation of major electrification schemes, including Cardiff and Swansea, Windermere, Oxenholme, and Selby and Hull. Right, so we've got a number of constraints to also consider, and that is the energy consumption that we need. This is a graph come from the RSSB, and we've got regional, suburban, and intercity. And if we take a typical intercity vehicle, then to go 500 metres will take approximately 80 seconds from start. And in that time, that intercity vehicle would need over 20 kilowatt hours just to go 500 metres. If we take a typical journey up the East Coast Main Line, could be as much as 174 miles. We need a considerable amount of energy. We've also got constraints of the vehicle. If we take a typical Class 165, which is diesel multiple unit, the tank size is 1,100 litres of diesel. It has an approximate range of 1,500 miles, and it has a refueling every 3 days. So we have an operational constraint here where the unit may not return to its base for 3 days. So it sits in sidings, it sits in a train station somewhere at a point where it can't be refueled. So we need to be able to have that capacity as well, so we don't change the operation. So where could batteries work? Here is a typical route map from Grand Central. Excuse me. This is, for all keen people who are in the railway, is the East Coast Main Line, and that's electrified pretty much all the way up. Currently, what we have is the Selby to Hull line is not electrified. This is known as a branch line. What this means is that we can either run an electric train all the way up to Selby, where passengers have to disembark and then go to Hull on a diesel train, or more recently, we've had bi-modes produced which run electricity all the way to Selby, and then it goes under diesel, but it's still working on diesel. It's just the passengers don't have to disembark. Currently, the East Coast Main Line still pays host to a number of diesel units as well, so they run the entire route on diesel alone, which is politically not really liked. Secondly, where else could they work? If we take our major city hub of London, this has a ULEZ in 2019, as you can see in orange. Sitting just outside this ULEZ is Marylebone Station. Marylebone Station has a number of diesel units that come in, and they run through through London. That ULEZ zone is set to increase in 2021 to the inner ring road. That means that our diesel trains will be running in a ULEZ area. So whilst they make great gains to remove the automotive industry of diesel with it, we're then providing that hotspot along that rail line and into the hub of Marylebone Station. So what we're doing about it, we've looked at our Class 165s that go into Marylebone, and we're looking to produce a self-charging hybrid. The concept itself was born out of repower. We looked to repower. What we've got is a number of systems on there that are obsolete. We overhaul the engines, we overhaul the transmission, but we're finding parts are becoming harder to come by. We reached out within the rail industry to our suppliers, and they could supply us a new diesel engine to supply the diesel engine. So we've still got the problems that we're still running 100% wholly on diesel. So we looked at hybrid and what the opportunities this presented. And it gave us a step change in environmental performance. We're reducing our fuel usage by 25%. So we're in fact reducing CO2 by 25% and then reducing NOx and PM. It's got benefits in operating costs to our customers by reducing the amount of fuel we're using. We've replaced those problematic engines and transmissions, and it continues to offer that range that we require, those 1,500 miles and 3 days of refueling. As I said, the rail industry didn't offer this, so we looked outside that rail industry to who else was out there. And we found this company in Sheffield, Magtech Hybrid and Electric Vehicle Systems, were doing, they were changing buses and lorries, so why couldn't we scale it up to a rail vehicle? So what have Magtech come to do for us? What we've done is we've removed our equipment. So we've removed our engine, we've removed our hydrostatics, and we've removed our transmission from those rail vehicles. In its place, we've fitted a new 400 kilowatt traction motor, we've fitted new batteries, and we have engine generators, so we're a self-charging hybrid. And obviously we've got new controls and RCM. How does it work? Basics. Basically, when our engine generators are running, we're charging our battery and we're also supplying our traction motor directly. When peak power is demanded, the batteries also parallel supply that traction motor as well. When we go into battery only mode, we are now at 0 emissions at the wheel. So our battery is supplying our traction motor wholly. Using geofencing, we can stop those generators from powering our battery. So when we're rolling into stations or rolling into ULEZ or anybody else's cities that don't want to have emissions. This also affords us the chance to regenerative brake as well, further reducing our dependence upon diesel to charge the battery. Now this is on works now. This is based in the Ram in Derby. Here's our diesel vehicle, class 165004 on its stilts. At the top right, we have a 400 kilowatt hour permanent magnet motor. That's actually derated to 200 kilowatts, but it allows us redundancy and it allows us to transfer that to other vehicles should we wish. And on the below, we can see that we've got the wraps ready to be fitted on board our vehicle. Now, just to give you an insight where we come from, where we got the battery sizing from, we work this out through, this is our battery. We work it out through route profiling. So we run the routes through a computer, what they run at currently with a diesel, what they require from a battery to be able to produce that same operational performance. For our hybrid vehicle, this gave us a capacity of 180 kilowatt hour. We're using an NMC battery, and it gives us a range of 15 miles on battery alone, which doesn't seem like much, but it's quite critical when we come to look at the next slide. And it gives us a time of battery of 30 minutes on battery alone. As I said, what does that 15 miles mean? Well, here we are, right at that very last point, that's Marylebone Station. As you can see, we've got a line going out 5, 10 and 15 miles. That 5 miles is the 2021 ULEZ zone. So suddenly we now meet the Mayor of London's aspirations to have ultra low emissions within that perimeter. We can look to start going further out to 10 miles, but actually if we go out to the maximum 15 miles, we're at the M25 corridor now. So we are really providing a step change in emissions for the capital. So what are the benefits of hybridisation for us? It obviously has environmental benefits. We reduce CO2 by 25%. We have big reductions in NOx and PM, sorry. But we're not losing the benefit of embodied carbon by not having early replacement of those vehicles from an electric vehicle. By making them go longer, we reduce the embodied carbon. We have passenger benefits as well. We have improved air quality in stations, and engines will normally be off in those areas, and a quieter passenger environment. Operational benefits is reduced fuel, we reduce the maintenance cost, and we actually increase the range by not using the diesel all the time and running those engines at best point. We have performance benefits, but through the PM motor. The PM motor obviously helps us increased acceleration so we can get up to speed faster. We have reliability benefits because we remove the obsolete components and systems on the train. And providing, through the RAFs, we have an upgrade path to full battery vehicle or even hydrogen, dare I say it. So to conclude this, because I think my 15 minutes is up, hybridisation is our stepping stone towards lower carbon future. We've got immediate environmental benefit. We don't need any infrastructure requirements. So those £2 million electrical upgrades aren't quite needed. Modular approach for future upgrade potential. And again, like I said, we don't lose the embodied carbon through early replacement. And then there's benefits to both passengers and operators. Thank you.
Many thanks, David. That was excellent. Actually, we will be taking questions during the Q&A session later on. So if you do have any questions, please type them in the Q&A box and we will be picking them up in the end. I will now pass on to Mark Scully of ATI. Mark, over to you.
Thank you very much, Nicoletta. Very pleased to be here this morning. So welcome everybody. My name is Mark Scully. I'm the Head of Technology for Advanced Systems and Propulsion at the ATI. So for those of you who are kind of trying to work out what the ATI is, our mission is all about leading technology in air transport. We were established back in 2014 and we're an independent organisation. We're backed by government and industry, but we're an entirely independent organisation. We provide the leadership for the UK's aerospace technology community. And one of the ways that we do that is by defining the National Aerospace Technology Strategy. And I'll show you some elements of that in a moment. We lead the development of an R&D portfolio, which is worth £3.9 billion through to 2026. And unsurprisingly, we're already talking to, or have been talking to government for a while, about beyond 2026. That's not that far away in reality. So very exciting opportunities through the ATI in terms of funding support for aerospace technology. We're always seeking new ways to really stimulate our innovation. One of the ways that we've done that quite recently, we've launched we've had an accelerator that we ran with Boeing and support from GKN as well. That's now going to go into a second tranche of activity. And more recently than that, we've also been doing some work on a project called Fly Zero, which is looking at the next generation or a future generation of net zero aircraft, both in terms of technical and market feasibility. I'm just trying to get connection. So there we are. Look, so there at the bottom, what are we doing this for? It's all about technologies for greener aerospace, competitive aerospace, really about securing and growing high value skills, securing our global position in a growing market, and of course, capturing high value content. So a little look at our strategy next. If I can get on to the next one. So there we go. So we've published almost a year ago now, a document called Accelerating Ambition. Excuse me. You can find this on our website. It's a compilation of all of the technology themes that we've identified, or the key themes that we've identified, which are going to support the sector going forward. And within that, we've captured what we call our air transport vision. And our three key drivers were in the world of sustainability, mobility, and competitiveness. So sustainability was being thought of quite a while before other people started talking about elements of this, but it encompasses many, many different aspects. It includes the air vehicle itself. It includes how you operate the aircraft, so whether the aircraft operate in a single formation or whether you've got a fleet formation. It includes the manufacturing of the aircraft. It includes ground operations. It includes through life support. And it also makes us think about power sources, and hence the link today to batteries. When we think about things like mobility, so mobility was really driven around the fact that new vehicles that need to enter the market really need to be zero net carbon vehicles. And the little image that you can see there is of things like urban air mobility type vehicles, so smaller vehicles that are starting to come to the market. We then thought about the need for new business models. So those new vehicles that might come along may not be actually the same as operated by airlines in the way that traditional large air vehicles are being operated. So business models are a factor. A zero net carbon infrastructure. So how do you actually charge the aircraft? And then last but not least was about scalable air traffic management systems. So to really provide this mobility, you need to integrate all of those things together. And the last item that we've got on this slide was about competitiveness, which was really all about different things that our sister or parent organisation even, the Aerospace Growth Partnership. So they look at different measures in terms of industry support. They help to connect to customers, provide collaborative connections. Through the ATI, this is the arm of ATI providing technology investment. And then more widely, the UK R&C ecosystem, which is actually quite compelling for the aerospace sector. So if we move on to the next slide. So this is, it couldn't be an aerospace presentation without a few pictures of aeroplanes. So here's a few to have a look at. It's worth showing or worth explaining that the vertical axis there is really talking about the sort of size and range of aircraft. So things towards the top are the longer range aircraft, the higher passenger carrying vehicles, the more traditional vehicles that we see around us today in terms of commercial air transport. And we anticipate seeing those in the future as well. It's fair to say that we don't anticipate some of those, well, we know that they will not be adopting exclusive battery systems, but the batteries will play a part even in those in terms of some of the hybridization of some of those aircraft. Going a little bit further down the page, we can see the introduction of this dark green area here, the hybrid electric powered aircraft. So people are talking about a range of different aircraft that could come along, which really start to think about hybridization. David was talking there about hybridization in the rail industry, and we've also seen that in the automotive industry, and there's absolutely no reason why we couldn't see an element of that in aerospace as well. And at the bottom there, we can see the world of all electric powered flight, which is typically for the shorter range, smaller aircraft. But we would start to see the advent of some new, potentially new air vehicles in the near future, which would start to take advantage of electrification. It's also quite current and relevant to talk about the world of hydrogen. As you can see on here, it's mentioned that some of this segment here this market segment could also need to take into account the world of hydrogen. So if we move on to the next slide, I think you can start to see some of the challenges in the world of energy for aerospace. And it's really, and so on here, we're really plotting volumetric energy density against gravimetric energy density. So batteries are a part of that story, a really important part of that story. They don't, in their own right, they don't cover everything, but they certainly help to provide some of the short-range vehicles with an exclusive propulsive energy source. Even the larger, longer-range vehicles, which might use sustainable aviation fuels, derived from various different sources. To an extent, they will also have some form of hybridization, and batteries may also play a part in those. And even as we look at the introduction of hydrogen, whether it's through combustion of hydrogen or generation of electricity through hydrogen in terms of fuel cells, again, batteries are going to be really important for the sector in terms of supporting all of that. We're kind of keen to see this world of batteries progressing in terms of its energy availability and its power density as well. So all of those factors really feed in there. And when earlier on Martin and Anna were talking about targets, some of those targets are really quite challenging in the world of aerospace. Not least of which is the target around safety. So if I move on the subject of targets to roadmaps and targets. So On the right-hand side there, you'll see a very blurry roadmap, which is deliberately quite blurry. It is still quite very much in development. And at the top of that, there are some targets, which are actually a refresh of targets that were first mooted 2 or 3 years ago when we first published an aerospace roadmap for batteries. But there's the roadmap and the thinking that's gone behind this new roadmap, which is going to be delivered, will really start to take account of some of the unique challenges of this new world of sustainability, mobility and competitiveness. So the roadmap will cover things like battery cells, it'll cover battery modules and packs, and it'll also recognise the need to think about technology, the sustainability and the wider economic utilisation of the battery. We are, as it's been alluded to already, we're going to be engaging with the APC. We want to make sure that we're aligned. There's some real opportunities there to make sure that what this aerospace sector is doing is very strongly aligned with auto. And we would really be very encouraging of any other sector who wants to talk to us and share in a line their technology roadmaps. Our plan with our roadmap is to publish this on our ATI website when that roadmap is then complete. So that will be an extension to that UK aerospace technology strategy that I described a few minutes ago. And I guess, you know, one of the key difficulties around challenges for our battery technology, and Martin started to allude to it in terms of the multiplicity of different sort of missions within the sector. I've shown you a roadmap, a kind of a map showing the market in terms of different aircraft, different sizes. All of those aircraft are being used in very different ways. There is no one unique set of properties that we're looking for the batteries. We're looking for some very different battery capabilities. So what that means is there's lots of opportunity for people to provide lots of really exciting technology to deliver against some of those different mission requirements. Moving on, I think the next slide I've got is really to say it's not just about the battery itself. The world of aerospace is uniquely challenged in terms of both the scale of what we do, in terms of energy and power, but also in terms of safety criticality. And Martin will recognise the diagram on the right-hand side there, which I've deliberately decided to use elements on, Martin. So hope that's okay with you. But really, it's around, you know, we've recognised the need within the aerospace community that we need to think somewhat differently about actually developing batteries for the aerospace sector. And we need a national capability with state-of-the-art skills and facilities for battery development and certification, everything from material characterization through to full pack approval. So what we're really talking about fundamentally is around testing is a major challenge in the world of aerospace. And you've seen some elements of that already through some of the presentations earlier. But at a national scale, we have nothing that really represents all of the needs for aerospace. And integration is probably the second key thing that I would mention. So bringing together all of the battery capability into an integrated, certifiable battery solution is really critical. So we're currently working with both TWI and Warwick Manufacturing Group. They're leading some consortium activity to develop a proposal for developing this national capability. And I'd certainly recommend anybody who's interested in participating or understanding more about this, either contact me or contact colleagues at Warwick Manufacturing Group or TWI. Certainly keen to get a full support and utilisation from across the sector and from across organisations in the UK. And I think that takes me to my last slide, which I think that's me finished. Thank you very much.
Thank you very much, Mark. That was excellent. And both you and David mentioned hydrogen. And at KTN, we're also looking at hydrogen. So my colleague Stefan Eldred will be leading on a hydrogen economy innovation network. So it hasn't been launched yet, but if you would like to find out more or become involved, I will put Stefan's detail on the chat and you can get in touch. So many thanks, Mark. Excellent. So I will now pass on to James Gavin of the UK Defence Solutions Centre to give us an update on batteries for defence. So there we are. James, over to you.
I'm James Gavin. He is mandated and funded by the government. One of our roles is to promote better defence innovation. And firstly, I'd like to say thank you to Jackie Murray, who recommended doing this talk today. So under our mandate, we're working on defence and energy capabilities for operational advantage and efficiencies for the MOD, the UK Prosperity Agenda, so that's jobs, and also Net Zero Carbon 2050, where defence is part of the solution, not the problem. And I think that's a really key thing to think in mind there. I've recently been working to exploit and explore with the civil and defence cross-sector and co-funding innovation models between the MOD Defence Innovation Unit, the Army and DSGL, as well as working with different base funded areas like the APC and Faraday. And today I've just got 2 slides for you, and do feel free to take screen snapshots. This first one in particular you can see now. We're very much keen that you look at the bottom statement there, which helps you towards exploitation, hopefully with the competition which is coming up today. Keeping in mind that I'm there to help encourage you to bid defence ideas into this sort of competition. The first slide covers key challenge areas and opportunities that we need innovative solutions for which the Army and its suppliers want to exploit. The second covers some more key points to do with the challenges in the overall defence sector from DSGL's battery technology expert Darren Browning, and Darren will be taking part in the panel later. So if you've got any hard questions, please save them for Darren. Overall, as I was saying, defence wants to use better battery solutions for operational advantage and efficiencies. But the third thing, which is really coming to the fore there, is to help it meet legislation and policy. And it's important to highlight that the MOD is currently considering committing some very challenging net zero carbon policies, and also is not exempt from legislation like the internal combustion engine ban, which could be 2030 or hopefully it's then to keep us competitive. As the Army moves toward hybrid and EVs, that will bring really interesting battery challenges there, because there's a very strong thinking that potentially the batteries which are developed for road vehicles are not going to be good enough in the defence context. To start sort of talking through the slide a bit, and you can read it, do read it offline and digest it, particularly that final statement. At the moment, I'm seconded to the Army, and I'm working with the Future Force Development team to identify and the business case need and start to deliver a battlefield electrification strategy. Within that, they want to invest in innovative solutions, taking those through low TRL levels to the higher TRL levels towards exploitation, and principally that means ruggedized batteries. So where deployability into harsh environment, hot, cold, high vibration impact in environments, wet and dirty, batteries which are more survivable. Think about kinetic damage, so things like bullets. What happens if you shoot a battery? I think the assumption is that they catch fire. What happens if there's fire in the vehicle itself, for example, or other systems? But also reliability is very, very high up the list as well, to reduce logistics burden, longer longevity. For example, when batteries are in storage, less failure rates. There are other reasons we're looking for better batteries against emerging use cases. And so principally in my mind, where the step change will be is the hybrid and electrical land vehicles, as the armies across the world start to migrate to those. Energy storage over deployed generation. Why deploy a diesel generator if you can store the energy you need in a larger battery? But there's other defense systems there as well, which are becoming more prevalent, whether it's radars, sensors, you name it, deployed soldier solutions as well. A key topic for the Army is standardisation and interoperability. You know, the DEF stands, as they call them, defence standards, are not as established as maybe they are in the civil sector if you start looking at hybrid electrical vehicles, for example. But also interoperability really matters. You know, you don't want 20 different types of battery, which is what they feel that they're suffering from at the moment. Lighter and smaller, particularly for dismounted soldiers and air systems. More energy density in some areas, ability to cope with higher voltages, surges of energy. But also then there's legacy systems. It might, you know, use very old lead acid batteries. I know the US Army is particularly interested in replacing a lot of legacy batteries, you know, hundreds of thousands, with more modern solutions which meet their needs. One of the key things that we really want to put on the table to consider is that cross-sector markets really matter. Now, if you think about off-road 4x4 vehicles, you're also sort of thinking, as well as for defence, that they'll be of interest for mining, construction and agriculture, where the battery sort of needs might be slightly different there than normal on-road vehicles, for example. So the statement below, which I'm not going to read because you can read it yourself and digest it over time and what it means, has gone through their commercial team and legal counsel. But basically that is to support any entries that you want to put in sort of future competitions linked to batteries, that defence is very interested in sort of follow-on exploration and exploitation of solutions in the sort of space against their problem sets. So next slide, please. Stefan. So from listening and talking with Darren, who I mentioned previously, and also to OEMs and primes who also want your novel, new and better battery solutions, you know, it's very clear that there is a strong and emerging need for ruggedized and better batteries. There's a clear need for innovation over and above what exists already. And that investment and exploitation is what the defence domain wants to start investing in, whether it's the OEMs or whether it's the MOD, UK MOD itself. So technical requirements, you guys on the call are going to be more aware than I am, are very similar to the Faraday targets, but the differences are those acceptable compromises. And I was invited to take part in some of the discussions from this innovation network that have been going on. And all the compromises, whether it's a UAV on one side through to a heavy vehicle, are very different. But keep in mind, everyone wants the best solution for those particular use cases that they might have. And there are a variety of different compromises to balance out. And some are on that list there, which I'm not going to read to you. Now, please do digest offline. But exploitation with defence is also worth mentioning to you as well, because defence and the industry users associated with defence might be able to exploit products before they meet the wider needs of mainstream markets. They might be willing to fund them ahead to be early adopters to give that advantage. And it could be a stepping stone for you onto other opportunities. What I would say is the defence export market, particularly into the United States and wider NATO, which is accessible to the UK, is you know, very, very strong indeed. I think Europe will particularly looking at electric vehicles for defence first because of legislation, whether it's Norway 2025 or the Nordic states 2030, and hopefully the UK following suit. I'd definitely say that this network that you're joining today and continued sort of things in the future will be a really good platform to discover more about you know, the challenges and opportunities. But finally, I'd just like to say good luck with the competition and keep an eye out for what emerges from this Army electrification strategy, as well as the MOD on emerging policies over the next year as the integrated defence review starts to be published.
Many thanks, James. That was excellent, and it's actually great to see that defense is really interested in batteries. So we hope to see lots of collaborations in this space in the future. So we will be now looking at the next steps, and after that we'll have another chance for Q&A. So I already saw some questions coming in. If you have any more questions, please pop them in the Q&A box and we will have a Q&A session at the end. Thank you.
Hi everyone, my name's Sheena Hindocha and I'm from the chemistry team at KCN. I'm sorry that I can't be with you this morning. I'm on holiday, but I hope you've had a good session there. The agenda looked excellent, and I'm looking forward to listening back to the talks from this morning. So I'm just going to spend a few minutes talking about the next steps in terms of the cross-sector battery systems innovation network and what we're going to do. So as Nicoletta told you earlier, there is a key mission within this network, and it's really to open new markets for the battery industry, promote innovation, and by doing this, we will help to decarbonise a wide range of end-use sectors, really supporting that net zero agenda and addressing climate change. So that's really core to this innovation network, and it's really important to us. So what do we want to achieve? So we're looking to develop and foster those UK supply chains around battery systems, but beyond automotive. There's been some amazing work already done within the automotive sector, and we're just wanting to extend that into different sectors so that we can learn from each other and leverage the activity that's already been done. By identifying this cross-sector commonality, we're hoping to be able to accelerate some of that innovation and make it easier for people to find partners, identify different companies within the supply chain or institutes that they want to work with to drive this forward. And by doing that, we're hoping that we will enable networking and collaboration and really drive some of that. And we want to be the voice for the emerging supply chain. So these new supply chains that are being created across different sectors, we can help to consolidate that. So, but what are we actually going to do and how are we going to achieve this? What's our plan? So what are we going to do next? We're going to create an online hub. And this cross-sector battery systems hub will provide information around companies and organisations that either want to use batteries or are interested in the production of. So this is for the whole supply chain and all end users to try and find those partners, to share challenges and opportunities, to work together and collaborate, as well as being a place for news and funding opportunities. So we're hoping it will be a place to go if you're looking for anything battery related, for information on companies and what they're doing, to find partners and just sort of explore the space with lots of content. So how do we intend to do that? What's it going to look like? So I've got an example here of something that we're planning on doing, which would be a sort of a landscape map. And this is using dummy data, so it's not real data. So please don't worry about that. But it's just an example of one of the things we could do. So in this case, we've got a list of companies. We've categorized them by the type of organization they are, whether they're a company, a university, a government organization, or a RTO. We've also categorized them by their end use sectors. So what sectors are they currently active in, or do they want to play in? So again, if you're in rail, you can come and you can filter these organizations by those that are active within the rail space. And we've also looked at supply chain, so we can categorize companies and universities again by the space they play in the supply chain. Are they on the cells and materials side? Are they working in the battery management system? Are they part of recycling? So this is just an example of what we could do. There are many other different categorizations we could use, but this is just ones we thought would be most useful to start with. And again, this is dummy data. We're going to be building this, this data set for the next few months before producing the map and moving forward. And we've got some experience in this. Previously, we've done a chemical manufacturing landscape map, which is embedded on the KTM website, but this battery one would be in the online hub. And you can go and you can explore it. And there's multiple different ways we can look at this categorization. So in the case of the example on the right here, we've got technology strengths. We've also looked at feedstocks and products, and TRL level, but we might want to do something different for the battery systems network. So we could look, again, as I said, at end use at supply, but also TRL. Are there any other key interests? So if you've got any ideas around this categorization and what you think will be important, and also what you think will be useful, what do people want to look for within this? Because we really want to make sure that it's valuable to the community and to the people that are accessing that hub. So we'll be doing this over the next sort of 6 months or so and developing it. And it will be an iterative process. We will be taking feedback, understanding what works, what doesn't work, and redeveloping it as we go. In addition to that sort of online space, which will allow access to information and contact with partners, we also planning a series of events called Batteries For. So already today, there were some talks around specific sectors, and we're going to build on these and explore sectors like defence and stationary, marine, rail, and explore the challenges and the opportunities within them, understand the technical difficulties, the gaps, and try to bring the community around from across the different supply chain to address those challenges. We're also looking to explore, that recycling and end-of-life opportunity, as well as the material requirements. So how will those supply chains build up around these opportunities? We are planning these and look out for them. Hopefully there'll be one coming your way soon. And yeah, well, hopefully I'll be there in person next time, and maybe at some point in the future it will be a face-to-face event, but I guess who knows at the moment. So we've got, some really exciting stuff planned, and this is the team that's delivering it. I think Nicoletta showed this to you earlier. We're a cross-sector team working on this, cross KTN, really exciting group of people to be working with. So get in touch with us if you've got any feedback or comments or want to speak to us about something else. So we don't just do batteries, we do lots of other stuff. So please reach out and be happy to speak to you. So that's almost it from me. So how can you get involved? So register your details on the website, and that will sort of add you to the group, but we'll add you to a mailing list, and we'll start to collect details on, so we can start building our database as well. Nicoletta is going to share that link with you in a moment. If you've got ideas about what you want to see in the hub or on the landscape map, get in touch. We want to make sure that this is for the community and it is going to be used and useful to that community as well. And any ideas, these cross-sector challenges or opportunities, again, get in touch. We're always happy to talk to people. So thanks for listening. I hope you've had a great session this morning, and sorry I couldn't be there again. I hope to see you all very soon. Thank you.
Perfect. That was great. And how technology works. Actually, Sheena is currently on a Greek island while we heard her broadcasted video, but it was all perfectly timed. There we are. So we will now pass on to the final Q&A session for today. We have already a few questions coming in, but if you do have any final questions, please type them in the Q&A box. Starting on from David and Rail. What challenges do you currently have that innovation could possibly help with? I imagine safety is a key concern.
Yeah, hello. Safety is always the major issue in rail, and for that reason that we're always behind the curve where technology is going. Those curves are starting to merge a bit more now, so we are getting a bit more quicker to get things to market. But yeah, safety is the major concern. We've also got major constraints with regards to meeting capacity, the range required, as I stated, with diesel, and then major issues with trying to keep the weight down as well, and just space as well. I know we've got rail vehicles themselves, but with the amount of power that we require, needs quite a chunk of battery to go on the underside, and then we're restricted on space as well. So there is major challenges. I mean, the biggest one really that's really affecting the progress of this is purely comes down to financial, and it's the cost. There is a high cost because it's low volumes, and how we meet those challenges, because there's no legislation to drive us that way, and we're very much reliant on, well, it comes down to its public money. So it will come from the government, and it will come through people's tickets to pay for those modifications, which are hugely expensive, as you can imagine. If there is, if there's specifics that you want to answer, feel free. I'll put my contact details in the chat now, and feel free to contact me if you have specifics in that region that you want to talk about.
Thank you very much, David. And there's another question for you. Did the conversion to a hybrid drivetrain add additional mass to the vehicle? If so, does this result in fewer passengers being carried?
Again, it's one that we've got to find the sort of the sweet spot, if you like. One thing we don't want to do is reduce the amount of passengers, because essentially that's what pays for the train, and all franchises up until now have been based on getting the bums on seats, if you like, and ticket sales is crucial to that. So restricting the amount of passengers is difficult. Actually, in the original plan, the weight was going to come under, and we had to be careful, because if it came under a certain amount of weight, then we would have to we'd have to look into the brake forces of the vehicle and that operation, that safety side. So we were keen to make sure that it was almost weight neutral at this point in time, to avoid any unnecessary changes to the existing vehicles. So yeah, so actually in effect we are weight neutral at the moment, which is the positive thing.
Thank you very much. And then there's a question for Mark. Does the ATI exclusively work within commercial air transport, or do you cross over into GA and other categories?
So that's a great question. And the simple answer is that we're all about economic growth for the UK. So traditionally in the past, that's been in the commercial air transport sector. It's likely to remain in the commercial air transport sector, but we're keen to talk to people where there are opportunities in the smaller end of the market, the small capacity air vehicles. We're currently funding a project which got to a very exciting point in its activities, a project called Accel, which is led by Rolls-Royce, but it's supported by YASA, who have come from the world of automotive with their motor technology, moving very swiftly into the world of aerospace, but also Electroflight, who are really leading some significant activity within the project on some of the energy storage and the battery technology in particular. So that's a particular project where we're looking at a very small aircraft, which is actually planning to do an airspeed record. Very exciting project, actually. Very much looking forward to seeing how that progresses. They got to the point just a couple of days ago where they actually rolled out. They did a lot of their ground testing, and it got to a very exciting point within the project. So very big opportunity there. But the real answer is we're very curious. We're keen to talk to people where there are energy storage opportunities in the world of aerospace, probably regardless of the size, because what we see is that a lot of the things that are coming in the smaller end of the market tend to propagate and scale up, not scale up directly, but will lead to new opportunities in the larger end of the market as well. So all of those things lead to economic growth. So that's quite a long answer to the question. Hopefully that makes sense. Thank you.
Thank you very much, Mark. Yes, and that made perfect sense. And then I can see a question which I think actually goes to me. So when will this hub be ready for access? So it will take a few more weeks, and that is, we are trying to get it right. So we want to make it useful. We want to make it easy to access. We want to add loads of content to it, so it's taking a while to develop it. But in the meantime, there is an interim standing landing page for it. The link directs you to a KTN page, and we will be adding news and links for the time being there. And obviously, it would be great if you can start signing up, and then we can keep collecting all your details and data, so that when the hub becomes available, you can be a registered user for that. So again, we will follow up from today's webinar with a link with all the material for that. Yes, so you will get all the links, so you won't be missing out on anything. So Oh, actually, I can see an extra question here, a final question. A question for all the panelists. In a perfect world, is there anything chemical companies can do to support the selection of the right chemistries within the cells? For example, certain metrics, specific tests. Thank you very much. So that's a generic question for all panelists, but is there anything chemical companies can do to support the selection of the right chemistries within the cells?
I was going to say, Nicoletta, I'll try and have a go. I think the answer is yes. It has always been a challenge. How do you get different people down the supply chain to understand where their technology fits? So the challenge with the chemical companies, as you know, is that it's a very long supply chain, and there's lots of precursors you even get through before you even get to making electrode materials. So I guess probably it is actually joining up in the likes of cross-sector groups, but also with Innovate UK cross-sector projects, where you can actually work with everyone from OEMs through to cell manufacturers through to the supply chain, because it's the best place for people to get to know where their new materials fit in context and what the opportunities are.
Yes, indeed. Anna, I'm not sure if you'd like to add anything to this. Yes, I can see.
Yeah. No, really just to echo Martin, is that collaborating with different parts of the value chain on this kind of activity is really powerful for understanding, yeah, as Martin said, how the different chemistries impact the end performance of the batteries, and what is really required from those cells and cell chemistries, and what can be handled with sort of more on the engineering side. So that is something that we've seen has really come through the projects that we've supported to date, and the kind of projects that we would like to continue supporting. So yeah, really that collaboration across the value chain is really critical for accelerating that process. So yeah, and don't forget this afternoon, we have got a briefing event for a new competition. So there might be some opportunities for that collaboration coming up shortly. But yeah, engagement through these groups as well is another way to do that.
Yes, thank you very much, Anna. And actually, you gave me an excellent cue so for my last slide, which is we want to encourage you to continue networking. We know it's difficult in the current circumstances. Meeting Mojo is an online networking platform, so you can sign up there, start building your profile. We will leave it open for the next 2 months so that you can use it to find partners, connect with others, so you can start messaging others. It also has a system integrated for video conferencing, so you can have one-to-one meetings, or you can just send your details there. So I can see Poonam just added the link to that. It takes up to 5 minutes to build your profile, but please do make the effort. I think it's worthwhile because that will enable you to see everyone else who's interested, read through the profiles, and try to schedule meetings. So I would strongly encourage you to have a look through Meeting Mojo and try to build your profile and find other partners there. Also, to not miss, as Anna said, at 1:30 today, the latest competition briefing event, round 4 for the Faraday Battery Challenge. Great opportunities, funding opportunities coming up, very relevant to the discussions we've been having today, so do not miss out on this. You have received a separate email with separate joining instructions from Shelley, so look into your emails. You'll find the joining instructions for that is a different link, but we are very much looking forward to see as many of you and even more this afternoon. So I think I will now say thank you to everyone for joining us. I've also included here the links for signing up to the group and the link where the hub will be coming live, our contact details. You'll be receiving the recording and the slides. So with that, I will say thank you all for joining us today, and looking forward to meeting you in the near future and speak to many of you this afternoon. So thank you.